I eat green carrots. What does that mean? Well, it's just a mnemonic that I learned back, in the Cretaceous period when I was in school, and I thought I'd share it with you. It's the way of memorizing Jupiter's 4 biggest satellites in order. So, let's see. So, known as the Galilean moons of Jupiter. Now, Jupiter, as we noted in the last lecture, has 79 moons that we know of today, but the first 4 were discovered in January of 1610 by none other than Mr. Galileo, who turned his telescope up to the Jupiter and lo and behold saw 4 moons. And you'll be able to do this later this week with your Galileo scope. So, if you haven't already done it. So anyway, the Galilean moons of Jupiter in order are Io, spelled I-O, Europa, Ganymede, and last but not least, Callisto. Okay, so there's my 4 letters. I eat green carrots. Okay, it's just a mnemonic. But I do want to say a few words about these moons in order. A couple words in general. They're all very large. Io is approximately the size of our moon. It's the smallest of the 4. So Io is about the size of moon, about moon-sized. And by moon here, I mean our moon. Maybe I should capitalize it, because when you see moon capitalized, that means our moon, the prototypical moon, moon-sized. So Io is pretty big, about the size of our moon, but it's the smallest of all 4. Ganymede is larger than Mercury. Okay. Ganymede is larger than Mercury. So it is very sizable indeed. It's the largest moon in the solar system. Okay. But Io is the most geologically active moon in the solar system. Okay. It is orbits Jupiter, innermost orbit. It's in a 1-to-1, let me use a different color here, a 1-to-1 spin-orbit resonance. Like the moon. Remember how the moon keeps the same face towards the Earth all the time. It rotates once for every orbit. It rotates once for every revolution. The revolution is the motion around the sun, or the moon's motion around the Earth. That's revolution. Rotation is the spinning on its axis. So the moon spins once on its axis for every single revolution around the Earth. In the same way, Io spins once on its axis for every single revolution around Jupiter. So it's in a 1-to-1 resonance. Okay? But it can't quite settle down into that resonance. Okay? Because it constantly is getting tugged by Europa. Every so often, every so often, Io passes Europa. Remember, Io's on the inner orbit, so it's going to be going faster than Europa, and it's going to be passing it periodically. Every time it does, it gets a little tug outwards. So Io can't quite keep the same face toward Jupiter all the time. Okay? Which is really kind of weird. Or it does keep the same face towards Jupiter all the time, but it doesn't do so in a nice, stable way like the moon does. Every so often it gets a tug from Europa. And so it gets sort of rattled a little bit back and forth. But the tidal forces from Jupiter are so big on Io, are so strong, that it still keeps that orientation, that football-shaped orientation towards Jupiter. Remember how the tides on Earth get a little football shape because of the presence of the moon. Well, Io itself, the very planet, the very moon itself, is stretched out, pointing towards Jupiter. But as it gets a little tug from Europa every time, it gets churned up. Okay, it's constantly getting churned up, constantly getting twisted and turned one way and the other, which keeps it completely geologically active. It has hundreds of active volcanoes on it all the time. It is almost perfectly smooth because its crust is not rigid like our crust is. It's almost fluid because it's being churned up all the time. And when you keep a planet churned up or a moon churned up like that, it never becomes solid. So it has these volcanoes on it which actually produce sulfur. Okay, so it's a horrible place to go. You wouldn't want to go there. It's not good for you. But it's very, very active. It is the most geologically active of any body in the solar system. It's the most geologically active body in the entire solar system. Hundreds of volcanoes galore. Volcanoes. Lots of them. And please take some pictures. Please go to Google and Google up Io and take a look at it. It is this garish yellow orange color with black spots all. It looks like a pizza that has gone bad. It's this garish yellow orange color with all these little black specks all over it. It is crazy looking. You won't believe it. Okay, but go check out some pictures of Io. Now Europa is quite a different beast. Okay, it is very of great interest to scientists for a very particular reason. And I'll get to that reason in just a second. First, I want to indicate that it is in a 2-to-1 spin-orbit resonance. So every time it orbits Jupiter, makes one revolution of Jupiter, it spins twice on its axis. Okay, so 2 sidereal days on Europa is equal to 1 year on Europa. 1 year, 1 orbit, or year is probably not the right number because that usually refers. Year is probably not the right word for that because year always refers to orbiting the sun. But it remains that when Europa orbits Jupiter once, it rotates on its axis twice. But that's not the most interesting thing about Europa. The thing about Europa that's interesting is that it's got a lot of liquid H2O. Now, its surface is entirely ice. You know how the North Pole, there's no land there, it's just floating ice? You know? Antarctica actually has land under it, right? But the North Pole is just floating ice. Imagine that the North Pole ice were thicker than it is, on average, and covered the entire planet. That's what Europa is like. That's what Europa is like. It is covered in ice, and it's active. Okay, there's a heat source in it. Well, the energy for the activity comes not only from the heat within Europa, but also from the tidal forces from Jupiter. But the point is that the surface is constantly being renewed. There are some craters visible on it, but not too many. And there's clear evidence of a great deal of activity. So it is active. But there's no volcanoes on it. It's an ice world. Okay? It is active, but it's got liquid water under the ice. That's where its liquid water is. Okay? There's no oceans or lakes like we have here. Again, it's as if the entire globe of the Earth were covered in thick ice. Underneath that ice, there is liquid water. Okay? And so there may be actually more liquid H2O on Europa than there is on the Earth. And for that reason, there's a question of maybe it harbors life. And I'll say here that we did overlook that question about Mars, the question of life on Mars. So far, there's no evidence of life on Mars, although there certainly used to be running water. And that's why we're interested in life on Mars, is because so far as we understand it, liquid water is a requirement for life. It is an absolute necessity for life, liquid water. Without that, you got no life. There is no liquid water on Mars in the way that we understand it. There is ice on Mars, plenty of it, but there's no running liquid water on Mars anymore. Mars used to be warmer, and there used to be running water on it, and that's why we are interested in seeing if there's life there, or if there was life there. And that's the reason why we're interested in investigating Europa, is because we think that underneath that global ice layer, there's going to be a lot of water, and where there's water, where there is liquid water, there's a possibility for life. And that's the big interest in Europa. I'm not going to say much about Ganymede and Callisto other than to say that they are largely made of ice. In fact, most of the moons of the outer solar system are made of ice. And I will say the Ganymede is in a 4-to-1 resonance, so it spins 4 times on its axis for every one trip around Jupiter. Okay, so 1, 2, 4. Io is 1, Europa is 2, Ganymede's 4. Callisto, there is no resonance. The tidal effects on Callisto are far less, because Callisto is quite a bit further out than the other are. And the tidal effects on those are very large because of Jupiter's large mass. But returning to Ganymede and Callisto taken together, they are made almost entirely of ice. And this is normal for moons in the outer solar system. Unlike the moons of the Earth and Mars, which are rock, the moons of the outer solar system are almost entirely ice. And we'll say more about that, quite a bit more about that later on. So that's it for I Eat Green Carrots. See you next time when we talk about the blatantly superior planet Saturn.